to hand the webcast over to Lenny.
All right, thank you very much, and welcome. I'm so glad to talk to you about the new release of REMnux. It's been in the works for several years, on and off and on and off, and well, it's a big release, and I'm excited about all the changes, all the new tools, and so that's what I'd like to review with you during this session, let you know what you can expect, perhaps tell you a little bit about what's happening behind the scenes, and show you an example of how you might use REMnux to analyze malware in your own environment. That's the plan for this session. So if you're tuning in during the live session, then I'm also glad to see any questions that might come up. Please send them my way, and either we'll answer them during the session, or perhaps I will follow up with you if I can afterwards. So I suspect you would not have been tuning into this session if you didn't know what REMnux was about, but let me make sure that we're all thinking about this toolkit from the same perspective. This is a Linux distribution that I created a decade ago. It's incredible how quickly time flies. The first version of REMnux came out July 2010. And it is available and has been available for some time for free on rennux.org. It includes hundreds of pre-installed and pre-configured tools that I believe are useful for analyzing malware. Analyzing malware that's designed to work on Windows, on Linux, JavaScript, other forms of malicious scripts, document files, all sorts of stuff. There are a lot of amazing tools to perform the kind of work that work really well under Linux, but it takes time to configure them, set them up, avoid any conflicts, and that's what REMnux provides to you. And it's been gaining in popularity, and I'm glad to see that. And in fact, I have seen some people refer to REMnux as a similar tool that penetration testers would use for Kali. Malware analysts are looking at REMnux with a similar objective in mind. Now, REMnux version 7, the one that we are currently discussing in this session, came out, well, July 2020. It is based on Ubuntu 18.04, and the architecture has been created, or rather recreated from scratch. It's a full rewrite, which is one of the reasons why it took so long to put this out. But the reason why you as the end user of REMnux might care about the backend architecture is that the way the distro is designed now will make it easier to keep it up to date and will even facilitate compatibility with future versions of Ubuntu, including hopefully version 20.04. But right now it's based on Ubuntu 18.04, and one major change in this version of REMnux is that now it is based on a much more full-featured graphical user environment, which is GNOME. You know, I try to keep REMnux as lightweight as possible, and that's still my objective. But the types of systems that analysts are likely to use today, fortunately, are much more powerful than what was available to us, let's say, 5 years ago. So now I feel comfortable adding GNOME, but it's not the default GNOME installation, which is way too bulky and, I believe, bloated. This is a lightweight installation of the GNOME user interface, which allows you to interact with the tools in a way that I think is very, very productive. And as you would expect, this latest version of REMnux has undergone a lot of cleanup, which means that some of the older tools that are either no longer maintained or perhaps are no longer necessary are retired. And there's amazing new tools that have appeared on the scene. They're available as part of REMnux as well, and all the other ones have been refreshed. And also something that I'm quite excited about, there is a revamped, brand new documentation site that I highly recommend you look at while getting started and perhaps throughout your use of the REMnux system. Just to show you, if you go to, well, rennux.org, it will give you a link to docs.remnux.org. And it took a lot of time to set this up, the documentation, but I'm pretty happy with how thorough and accurate it is in helping you understand how to set up rennux and how to make use of it on an ongoing basis. So throughout this session, I'll be making several references to the kind of information you can find on docs.rennux.org. I also wanted to let you know that while I'm the founder and primary maintainer of this distro, there are several other individuals that have been contributing to the latest release. First of all, there's Corey Foreman, who has gotten involved with this distro as a major contributor and has been putting a lot of time and sharing his expertise in packaging the tools, testing them, configuring them, and helping move this distribution along. So huge thank you to Corey. Also, Eric Christensen is involved behind the scenes. He is the architect and advisor regarding the new backend configuration that is used for REMnux version 7, and I'm very grateful for his assistance throughout this project. And also, it is very important to recognize all of the authors of the tools that comprise REMnux. And by the way, if you install REMnux and you go to the menu, the visual menu that is now available to you, you're going to see a set of icons like this. And so that's pretty handy. As you can see, there are some GUI tools available on REMnux now. These include crowd favorites like Putter and Ghidra and CyberChef. We also have Network Miner and Wireshark. By the way, also, there is now Visual Studio Code Editor available, which is right now my favorite editor for text and scripts and code. So yes, we do have a number of GUI tools now available on REMnux, but the majority of the tools are command line based. They don't have an icon in the menu. And that is why I pointed out that thorough documentation site that lists every malware analysis tools that you're going to find on REMnux. Now, you can install REMnux in several different ways. First of all, you can download the pre-packaged OVA files. These are the virtual appliances that I created so that you can import them into whatever hypervisor you're using. There is a page on the documentation side, not surprisingly, that describes this. If you go to get the REMnux appliance, you will see that you can download either the general OVA appliance, which is one that's appropriate for most hypervisors, or for ease of importing into VirtualBox, there's a VirtualBox specific appliance that you can download and import, and you'll be off and running very quickly. So that's good. We've got the virtual appliances available, but sometimes it'll be easier for you to install your REMnux system from scratch. And for this, we now have a brand new REMnux installer and upgrader. It's a tool called, REMnux. So if you want, you can set up a brand new Ubuntu 18.04 system, and I suggest that you start with a minimal version of the distro, the one that has as few bloated applications as possible. Then, and again, not surprisingly, I have instructions for you for how to do that. Then you can, as described here, you can download the REMnux installer from the rennux.org website. Check its hash to make sure that it's the one that is indeed associated with the project. Rename it, copy it into your user local bin, set up GNU-PG if it's not already installed, and then installing REMnux on a compatible brand new system is as simple as typing sudo remnux install. Now here you have a few options available to you. You can install REMnux just by default. REMnux install is appropriate for most people. Or if you already have an existing system that you like to use, for example, SIFT workstation is one popular choice. If it's based on Ubuntu 18.04, then you can run the installer with the option install --mode add-on. I think I made a typo here on the slide, but the documentation site presents this option properly. Then it will install a REMnux on an existing system, and the add-on mode does not modify your existing user experience. so that if you have a system that's set up just the way that you like it, the add-on mode is not going to interfere. It's just going to install all the underlying tools. Also, it is now possible to install REMnux in a way that's friendly towards cloud-based deployments. So you can deploy either import an OVA file into your cloud-based environment, or maybe easier, set up a brand new Ubuntu 18.04 virtual machine in whichever cloud provider you prefer to use, and then use the REMnux installer. But in that case, remember to give it the parameter --mode cloud. The one thing that this will do beyond the typical default installation is it will not turn off SSH. When running REMnux in your lab, I suggest that you disable SSH unless you really need it. Then you can enable it for the duration of your experiments, perhaps. But in a cloud environment, people generally use SSH to remotely access their REMnux virtual machine. So --mode cloud will avoid turning off SSH. Again, all of this is documented on the REMnux website, and I've got some screenshots to show you what it would look like if, for example, you're importing the REMnux OVA file into VirtualBox. Just a few clicks will allow you to import and then start up the REMnux virtual machine. And if you haven't already done it, this is what you could expect it will look like if you import REMnux into VirtualBox. Now, it is also possible to run a REMnux as a Docker container. And I'm not talking about running very specific malware analysis tools as Docker containers, which is actually also part of the REMnux project that I'll touch upon briefly in this session. But the whole distro can now run as a pre-built Docker container. Now, this Docker image that I set up is available from the Docker Hub. That's the website that Docker maintains for such images. And there's a REMnux specific repository there. And so if you have Docker installed, then let's say that you wanted to get the REMnux distro as a Docker container and get a local interactive shell into it. Then you would say docker space run --rm-it means that you want to have a container that's only going to exist for the duration of your session. Then you specify that you want to use the user REMnux, which is what I always recommend you do whenever interacting with the REMnux distro. The user that is set up by default named REMnux has all sorts of nice environment aspects set up to make your job easier. Then you specify the name of the image which is present on Docker Hub, which is remnux/remnux-distro. Then you specify that you want to get a bash shell into it. And conveniently, if this image isn't already present on your system, Docker will automatically download it and give you an interactive shell into your REMnux environment. That's pretty convenient. If you want to make sure that you have access to your local files from within the Docker container, you can do that as well. That's the -b parameter. And also, if you prefer to interact with your Docker container remotely, perhaps because you want to run it in a cloud environment, you can deploy your Docker container in a remote system, then map its port 22, for example, for SSH access, and now you can remotely log into your Docker container. And this even allows you to tunnel your graphical user environment, maybe through X11 tunneling, or maybe you want to deploy VNC. There are instructions for how to do that on the REMnux documentation site as well. So as you can see, there's now a lot of flexibility that just wasn't there before. REMnux is easy to deploy as a virtual appliance, but it now also is available for easy deployment in a cloud environment as well as in a Docker container. So here's what it would look like if, for example, you wanted to run REMnux locally as a Docker container. This is the kind of stuff that I just mentioned on the previous slide. You can see that here I deployed Docker as a detached container. I'm mapping port 22 because my plan is to SSH into it. Now this I could do on a remote system, but I'm doing it on my local box for demonstration purposes. And then once REMnux is running that way, I can just SSH into it. And by the way, you might already know this, but if you're logging into your REMnux system remotely, the username is REMnux. The default password is malware. So that means that if you're deploying your REMnux system on an internet accessible environment, make sure that you change the logon credentials, perhaps use a set of SSH keys for proper authentication, and harden that box if you're running it outside of an isolated laboratory environment. So in this case, I deployed this REMnux container, mapping my local folder where my malware might be present into the container. And here, for example, I can see that once I'm inside of this container, which I accessed using SSH, I can now see my malware samples. In this case, it's sample.7z. Now, behind the scenes, I wanted to tell you, just in case you're curious, that REMnux relies heavily on a tool called SaltStack. SaltStack allows describing the configuration or the desired state of the system using a series of very powerful config files known as state files. So for every tool that is installed on REMnux, there's a state file that describes how SaltStack should install it and configure it. Now, as the end user of REMnux, you don't care about this. You don't need to know this. It just hopefully will get installed correctly and magically. But in case you're wondering, how does this thing actually work behind the scenes, I wanted to show you briefly what is involved. A state file, and I'll show you an example of that file in just a second, can direct SaltStack to install a tool as a perhaps apt package, or as a pip module for Python, or by directly downloading the tool off a specific website. The state file can also specify how the permissions of that file should be set up. It could change certain aspects of the downloaded tool as well. It could also adjust the state of services or other settings on the system. Now, when you use the REMnux installer to set up and upgrade your system, what the REMnux installer actually does is it downloads the latest versions of the state files that describe REMnux. It copies them to your local system behind the scenes, and then behind the scenes, it involves SaltStack telling it to apply those state files to your system. This way, as new tools are added to the REMnux distro, or as existing tools get tweaked, updated, or reconfigured, SaltStack will make sure that whenever you run your REMnux update, you get the latest versions of these tools. And all these state files, in case you're wondering, they're on the GitHub repository that exists for REMnux. Look it up if you're curious what actually happens behind the scenes. You can find the REMnux GitHub repository, and I'm talking about the files that you will find in salt-states repo on GitHub. And here is an example of a state file that you will find on GitHub if you care to look. This one describes how SaltStack should install a tool called PEcheck. Now, in the beginning of the state file, there are some comments that describe this tool. In fact, the REMnux documentation, parts of it, is automatically generated by parsing these header files to make sure that the listing of the tools on the REMnux documentation website is up to date, to make sure that you know where the tool came from, to make sure that it is categorized properly, and very importantly, to make sure that you know who the author of the tool is. In this case, it's DDA Stevens, and what the licensing of the tool entails. Now here, as you could see, the SaltState file begins by, in this case, specifying that to install PEcheck, SaltStack needs to download it off this URL. It requests SaltStack to make sure that the hash of the downloaded file matches the expected value. It tells SaltStack where that file should be copied on your local system, and it specifies the permissions for that file to make sure that they are runnable. This state file also refers to another state file that is a part of the REMnux state files collection that is a dependency of this tool. PE check depends on a library known as PE file, and there's another state file as part of the REMnux distribution that describes how PE file should be installed. Also, after downloading this script and setting up the way that I just described, SaltStack is instructed to parse that downloaded file and adjust one aspect of the file. In this case, it looks for the pattern that you can see here, which invokes your default Python, which is typically going to be Python version 2, and it replaces that pattern to make sure that Python 3 is invoked. Whenever possible, REMnux tries to use the modern Python 3 version if the tools support that. There are some tools that don't support Python 3 right now, in which case Python 2 will be used. So this is what a state file looks like. And one of the reasons why I wanted to describe this to you is because I thought this would be interesting to know about, but also because now, really for the first time, the structure of REMnux allows other people like you, to contribute tools or fix issues with the way the tools are set up. Because each tool is described by its own state file, and this is all on GitHub, which means that if there's a tool that you notice is not working properly, and if you figure out the way to adjust its configuration, you can make the change to your local version of this repository, change that config file, that state file, and then submit a pull request to contribute your revision to the REMnux distro. And of course, I'll review the submissions and tweak them if necessary. And so this is wonderful because for so many years, I felt like I'm the bottleneck for keeping REMnux up to date. And even as people are getting involved, it was very hard for me to not be that bottleneck. And I hope that the new reliance on GitHub and state files really allows other people to be involved more actively in keeping the distro up to date and working properly. So as an end user of the system, if you want to keep your distro up to date, very simple. Run the command remnux upgrade. Let me show you. So I already have the REMnux system here set up. And to make sure that I have the latest version of all the state files and the tools that they describe, I type REMnux upgrade. That's it. Now, this command behind the scenes checks the released versions of state files on GitHub, and if there is a new set of state files, it will download them and automatically activate SaltStack behind the scenes to apply them. But in this case, as you can see, I'm already running the latest version of REMnux. I've already recently upgraded my local copy, so there are no upgrades available. Now, there is another way to use the REMnux tool, which I wanted to tell you about, which is using the command update, REMnux update. REMnux update gives you a way to refresh the existing configuration of your system, even if there is no new set of state files available on GitHub. Sometimes this is useful if you believe you've broken the configuration of some file, of some tool that comes as part of the REMnux distro, and you just want to refresh everything. Then you just run the REMnux update command. It will use the locally cached copy of the state files that you applied most recently, and it will just rerun SaltStack behind the scenes and reapply those state files. That can oftentimes fix various problems. Also behind the scenes, REMnux update will update whatever packages are available from the apt-based Debian style repository that Ubuntu supports. So this is a way to, let's say, lightly update your apt-based packages, fix up the configuration of some other tools without performing the full upgrade, which sometimes will not be available to you. So REMnux upgrade, when an upgrade is available, this is what it will look like. As you can see, it'll show you that it's going to be trying to download the latest state files and then reapply them to make sure everything is as up to date as possible. So I recommend running REMnux upgrade once in a while. I don't know, so once a month, maybe once a quarter, whatever you feel is appropriate for you. And also, if you're running REMnux in a virtual machine, I highly recommend you take a snapshot before you upgrade your system, just in case something goes wrong and you want to revert. So I told you about what is available on REMnux and how it is different in version 7 from the previous versions. I wanted to continue with that theme, but now I'd like to do this by showing you REMnux in action. This will give me a chance to showcase some tools, some of which are new to this version of REMnux. Some of them will be familiar to you if you have used REMnux before. And what I'm going to do here is use a malware sample that I came across just recently. The other week, I was reading a blog post by malware researcher Thomas Roccia, and he created this blog post that I highly recommend you read. It's called 50 Shades of Malware Strings. If you Google for it, you'll find it. Anyway, he talks about how strings can be used as part of the malware analysis process. A wonderful post. And one of the samples that he briefly mentions there is identified by the hash that you see on this slide. So I downloaded that sample into my REMnux environment, and I wanted to show you how you can start analyzing the sample with the help of REMnux. Now, we're not going to take this analysis from start all the way to finish. I'm just explaining how can REMnux assist with the analysis, how can you perform initial triage and perhaps perform some other analysis steps that REMnux can facilitate. So that's the plan. I wanted to show this to you right now. So here is what I suggest you do. When you have a malware sample like, well, the one that I'm talking about, I mean, here I have it in my environment. It is called, not very creatively, sample.exe. Where do you even begin? How do you start thinking about ways of making sense of this piece of malware? Well, this is where I highly recommend you turn to the REMnux documentation site. Did I mention docs.remnux.org? Yeah, of course I did. Now look, I already showed you that there are instructions there for how you can install the REMnux distribution. Next, I recommend that you look at this section called Discover the Tools. This is where all the tools installed on REMnux for malware analysis are described. And they're described in categories. So if you go to the first category, which is Examine Static Properties, you will see that there are several subcategories. For example, General. You see the various tools. You see the contents previewed to you on the right side. For every tool, there is the website that it came from, its author, if known, the license, if known, including a link to additional license details. And if you're curious about how a given tool is installed, there's even a link to a state file that REMnux uses behind the scenes to install this tool. Now, this is for those who like to get their hands dirty, but as an end user of REMnux, you don't need to know anything about state files. Why am I telling you about this now? First of all, I wanted to point out that this is my effort to make sure that you, as the user of all the tools that the authors have contributed, recognize that REMnux packages existing tools. I didn't write most of these tools. They're created by their respective authors, and they are really doing an amazing job contributing their expertise to move our industry forward. And so here you see names of all the people that made REMnux possible. Also, I suggest that you use this categorized listing of the installed tools as one way to guide yourself through the analysis process. When you have a new file that you're suspicious about, that you might want to analyze, start at the top. Examine its static properties. Then move on to statically analyzing its code. Then maybe dynamic reverse engineering of the code. So now you've got this step-by-step process that you can follow. Now that process will depend on the type of file that you're analyzing, on the context of your incident, on the technologies that are involved. But now you can see you've got a series of tools that are available to you. For example, we're at the very beginning of this file, sample.exe. it looks like it's probably a Windows executable, but we don't know for sure just yet. Where do you start? Over here. We've got a number of tools you could use: TRID, File, EXIF tool, and others. Some are applicable to this sample, some are not. So let's take a look. Here in my slides, I am summarizing which tools I'm about to use. I think this is going to be useful for you if you, after the session, decide to follow my analysis. The slides will summarize everything that you're seeing on your screen right now. So one way to start is by examining the file using the file command. The file command will tell us that this is indeed a Windows executable, and it even suggests that maybe it's compressed with a packer known as pcompact version 2. Now, it might be wrong about this, or it might be right. At least now you have some ideas for how to try unpacking this malware sample later on, if indeed that is part of your analysis objectives. Next, I might want to look at this file to say, well, if this is a Windows executable, what are the chances that it's actually malicious? Now, of course, there's a number of analysis steps you can perform outside of the lab. You can compute the hash of this file, you can look it up in websites like VirusTotal and so on, but most of the analysis that I want to do in an isolated laboratory environment where I have full control, where I cannot risk tipping my adversary that I'm actually examining their executable. And so most of the work that you can do within REMnux, you can perform in an isolated laboratory system. Although right now, the system that I have, that I'm showing you, is still connected to the internet, just in case, let's say I want to bring up the Firefox browser and maybe start Googling things. Now, the next tool that I wanted to show you is called Yara Rules. This is a script that invokes the signature scanner named Yara behind the scenes, and it applies a set of Yara signatures that are maintained by a community of security researchers and are available publicly. It will examine this file and tell us if it recognizes characteristics that are common to malicious executables. Now, it does not tell us that this is a malicious program, but it does tell us that this Windows program, when it runs, probably can communicate with the network over HTTP. It might have registry-related capabilities. It might have the ability to interact with a local file system. Maybe it is packed, and it triggers a few other signatures. Now, this is just a static scanner. It is, of course, going to be wrong sometimes, but you're just early in your analysis process, and you're performing these steps to decide, is this malicious? And if it is malicious, then how can I proceed with my analysis to better understand the capabilities of this suspicious executable? Now, there's also a simple antivirus scanner built into REMnux. It's called CLAM antivirus. It comes with a large database of signatures. Now, we all know the limitations of relying on signatures, of course, but if you can scan a suspicious file, and if you do get some signature match, then now you've confirmed that maybe it is malicious, and maybe you've even identified the name of the malware family that you're dealing with. So I like running a local CLAM scan on an executable before I spend any more time analyzing it. Now, this can take a bit of time to run, and also, as the REMnux documentation will tell you, before you run CLAM scan, you should refresh your signatures. For that, you would need to initially and temporarily connect your REMnux system to the internet. You would run the command fresh clam to download the signatures to your local system, and then you can disconnect, and therefore clam scan will function on an isolated laboratory network. In this case, it looks like we did flag this executable as being malware. Apparently, there is a match to a malware family known as Shayape. What is that? Maybe you've heard of it, maybe you didn't, but now you can take this name and perhaps look it up on the web and do some other open source based intelligence gathering. to see what do we know about this malware family. Keep in mind, early in the process, everything is signature-based primarily, and so the signatures can be wrong, and maybe ClamScan is wrong as well. We're just gathering data. We're going to be taking the data, and as an analyst, you'll be looking for patterns, trying to see which of your tools gave you correct and useful information, and which tools maybe are not very knowledgeable about a particular sample. Now, another tool I wanted to tell you about is SIGINT. SIGINT is also a simple scanner, and it looks specifically for signatures of references to cryptographic operations and common ways and algorithms in which malware can encode and decode data. So in this case, SIGINT scanned our malware sample, and it looks like there's a match of a signature, something about RSA SHA-1. Now, this doesn't tell us a whole lot because we don't know the context within which this signature was matched. But again, we're just gathering tidbits of information one piece at a time. And now we know that this is malware. Maybe it's called SHA-8. Maybe it has some ability to do something with RSA keys, maybe something else. We don't know yet. But again, REMnux gives you a whole lot of tools like these that you can see here in the documentation site for starting to analyze your malware. And sometimes Yara rules, as I just showed you, gives you the information that you need and you know exactly what you're looking for. Sometimes it doesn't, and so you will scroll down and try looking at this tool looking at this malware using some other tool. I'm just showing you one possible walk through this analysis. So we looked at static properties of this file from the general perspective, and those of you who will be reviewing these materials after the session will have these screenshots available in case you want to go through this analysis on your own. Next, I want to bring you to another area in the tool listing, which is going to be showing you tools that can perform static properties analysis. And these tools are specific for Windows executables, or PE files as they're known. There are quite a few tools that you can use for this purpose. And so let's get started. Let's see what might work in this particular case. Now, one tool that I like to use to gather a whole lot of data about a suspicious executable that is a Windows PE file is PE-Frame. There are several tools like it on REMnux, and some of these work better for some malware samples than others. PE-Frame gives you information such as the various hashes that represent this executable, including the imp hash. It tells you about what sections comprise this Windows executable. For example, there's a section named code here and a section named resources. Maybe that tells you something, maybe it doesn't. When I see a section named code, I'm thinking that's a little bit unusual. It's certainly possible. It's not malicious in itself, but that's a bit unusual. PE-Frame also comes with a number of Yara-based signatures that it can scan the file for. Sometimes this is useful, sometimes it is not. Sometimes you have already seen this information from an earlier tool. The tool also will look at the API references within this executable and flag those that maybe you want to continue your analysis with, such as, I don't know, it looks like this malware might have the ability to get the username of the victim. There are also some URLs embedded into this executable that maybe sometimes are malicious directly. These are not malicious URLs related to certificate-based interactions. So maybe this malware can do something with certificates. Now, another tool that I wanted to show you is PE-Check. Again, a similar tool to PE-Frame that gives you a lot of details about a given executable. Also hashes, also suspicious API calls, but it is a bit more verbose about some of the things that it is finding. For example, here I can see that the entropy of the resources section is very high. The entropy is a way of measuring the degree of randomness, and the higher the entropy, the closer that number is to 8, the more entropic or the more random are the section's contents. The high degree of entropy means this section might contain a compressed or packed content. So maybe this malware is indeed packed. Maybe the packed executable resides in the resources section. So you can start formulating these theories based on your static analysis with tools like these. Now, something that I wanted to point out here is that according to PE check, this file has an overlay. An overlay is data that is added to any file after the file is supposed to have officially ended. In fact, one way to carry malicious content into the environment and perhaps hope that the anti-malware tool doesn't notice that malicious content is to take a file that looks legitimate and then add encrypted or encoded contents as an overlay to that file. Windows will run this overall file just fine, and then once this malware starts to run, it can access its own overlay and decrypt its contents and then use them somehow as part of the infection process. So PE check tells us that this file has an overlay, which is in itself quite anomalous. In fact, we can use PE check to extract that overlay. The parameters are -go -d. Now I can dump that overlay into a file that maybe I'll call sample.exe.overlay. And now I have that overlay that I can extract and analyze on its own. For example, I can look at the strings within that overlay file, and maybe the strings will tell me something useful. In fact, if you spend a bit more time looking at this overlay, here I'm just extracting strings from it, you will see that it looks like maybe it is some form of a digital certificate, at least based on the strings. I see references to VeriSign. There's also some other strings that suggest references to Citrix. And there's also this interesting company name, dtoptools.z. So what you can do with a string like that is look it up online. In fact, earlier, we have identified the potential malware family name. We can now look it up on, I don't know, Google, for example. Yeah, you can, the name of the malware family was, I think it was shy8. Then plug in this interesting string, and now we come across a Krebs security website on something related to the certificate. You can see other malicious activity associated with this company name, and it turns out that this company's code signing certificate was stolen some time ago and used as part of malicious campaigns. What's strange is that those campaigns were active around the year 2014 and 2015, and yet the malware sample that we're looking right now seems younger. It's a relatively recent malware sample. So it's interesting to consider, why is it that we have this reference to what looks like an old stolen digital certificate being used as part of this malware sample? So here we're continuing to look at static properties of PE files. What other tools can we use here? How about extracting strings from this executable? PE stir is one way to extract strings from a Windows executable file. You can use other tools like strings, but PE stir in one way, one single command makes sure that you extract all possible non-obfuscated strings. You can look at the output, and frankly, here, as you scroll through this, if you give yourself some time, you won't notice anything we haven't seen already. So this is a way to examine static properties of PE files using some of the tools that I just showed you available to you. And based on the properties that you identify, you can decide, is this malicious? You can decide how might you analyze this malware in the future, and you can perform open source intelligence gathering, or as some people refer to it, Googling, to find additional context for the infection or the malware sample that you might be investigating. Now, there are a number of tools available on REMnux to examine static properties of your file, specifically with the goal of deobfuscating strings. You can see those tools listed here on the REMnux website. I just wanted to show you some of those tools in action. One tool that I like to use is XOR search. XOR search allows me to examine my malware sample, and it will locate common ways in which strings are obfuscated, which is, for example, using XOR with a key that is 1 byte long. Now you need to tell it what obfuscated substring you're looking for. And because I know so many malicious executables obfuscate URLs, I specified HTTP, and it will find for me a bunch of strings that include HTTP where they're not obfuscated, but also it locates in this executable that there's a string cmd.exe, which is obfuscated with XOR key 2a. Also, there are strings wellpoint.com that wellpoint.com is a legitimate website. This URL is obfuscated using XOR key 56. But by the way, if you look very closely on this URL, especially using a different font, you will notice that actually these are number 11. This is a malicious looking URL designed to mimic how a legitimate URL is. Wellpoint is legitimate, wig11point is malicious. Now, there are some other really awesome tools installed on REMnux. For example, Bergxor is a tool that looks for XOR obfuscated strings, and for every string that it decodes, it looks it up in a dictionary of English words to see whether it recovered the correct key. Here you see the URL, you see a portion of the URL related to view.asp. You see that there is a command as a string obfuscated within this executable using the key XOR 0A. And then there is a tool that's very handy called Floss, available to us from the folks at FireEye, that can look at your malware sample, and Floss emulates the execution of the program, and it looks for strings that might be dynamically changed when the program runs in the emulator. This allows you to identify even those strings that are encoded using more sophisticated methods beyond 1 byte long XOR. And here are some additional suspicious looking strings that you can recover using Floss. So as you can see, there are lots of ways for us to look for obfuscated contents within the executables that you're analyzing using REMnux. So we were just looking at the static properties of the file. It's metadata, references to API calls, strings. There are other tools available to you on REMnux, not surprisingly, where you can start digging into the code of the programs that you're analyzing. For static code analysis, you have a number of powerful tools installed now, including Ghidra and Cutter. Some of these tools can handle different types of binaries. Some are specific to PE files. So take a look at this. Let's say that you want to emulate the execution of your malware to see which risky API calls it might be invoking. One way to do it is to use an emulator called Beanie. And if you point it to your malware, it will pretend to run that malicious executable. It will intercept API calls that it is going to make when it eventually runs, but it's not actually running it. It's pretending to run it. So here, sometimes you get visibility into interesting APIs, like get tick count is sometimes used for detecting whether the malware is being debugged, for example. Get foreground windows, an API call that is also sometimes used to detect whether windows are changing in an environment to detect automated malware analysis sandboxes. There are references to memset and CW protect virtual memory. And these API calls, these functions, are sometimes used for code injection or unpacking. This is the kind of information that you can gather on REMnux statically, and then you can use this information in a Windows system if you decide to debug this malware. Now you know where to look, where to focus your attention when debugging it, if that's what you decide to do later on. But REMnux can run Linux-based tools. It does have a Windows emulator built into it, which you can use for some analysis tasks. But ultimately, if you will be debugging your Windows malware, you'll probably want to do it on an actual Windows system. Now, I mentioned earlier that REMnux includes a number of tools that are not directly installed on the REMnux distro. If the tools were a bit too heavy to install directly, they're available as their standalone Docker images that you can run as a container. You can run these images even without using the REMnux distro at all, or you can run them inside of your REMnux distro environment. For example, there's a tool that I wanted to tell you about called RETDEC. RETDEC is a set of tools that can disassemble and decompile and sometimes automatically statically unpack malicious executables. This decompiler, this toolkit was a bit too heavy to install by default on REMnux itself, but it is available as a standalone Docker image. You can run it outside of REMnux, or you can run it using this Docker command inside of REMnux. Here I'm mapping my local home directory into the temp files directory within this container. Now, I already ran this command when preparing for this session, so it already downloaded this image, and it's now cached locally. If it wasn't already downloaded, it would have automatically downloaded it for me. And now that I'm in that container, I can use the tools installed into that container that are not directly on the REMnux distro. So for example, I can go into my files folder. This is where my malware sample is available to me. And then the command available as part of this tool in its container is retdec-decompiler. This is a nice decompiler that can try to automatically decompile the code of this Windows executable and generate a .c file that might represent the source code of the original executable. So now it created this file for me that I can examine. Now, don't get your hopes up. It's not going to be that easy to read, and decompilers oftentimes get things wrong. And decompilers are very limited if the malware is packed, because some of the code is not visible statically. But now I can look at the decompiled file, and maybe if I scroll down far enough, I can notice some readable code. For example, here I do see a reference to get tick count. Our malware begins to run, it calls get tick count once to see what is the current state of the clock ticks that the CPU is tracking since it started up. That information is saved into a variable. Then it will call get tick count again, compare how much time has passed. And sometimes this is an anti-analysis measure. If the malware is running too slowly, it will assume that you're single stepping through to the debugger. And we're not looking at it that closely. We just don't have the time during the session. But that is one theory that would come into my mind when I quickly glance at code like this. So now I can exit this container. I'm back in my regular REMnux environment. Another tool that you can use to quickly assess the malicious capabilities of a sample that you're analyzing is called Kappa. Kappa, you can invoke it like this, and Kappa will emulate the execution of this malware, and it will look for references to risky capabilities. And it comes with a number of signatures to flag those capabilities. It has its false positives, of course, but look at this. It automatically noticed that our malware is checking for time delay via get tick count. Now, if you were decompiling the sample, if you had the expertise to examine decompiled or disassembled code, you would figure this out yourself, perhaps. But now you can see how, with Kappa, you can make sure that you don't miss the most important things. Also, Kappa gives you the specific offsets where risky things happen sometimes. For example, it tells us that there's a call to virtual protect that is sometimes used for process injection. That is happening at this offset within our executable. So what you can do now is launch Ghidra in your REMnux environment. Ghidra is now installed on REMnux. You can load your malware sample into Ghidra, which I already did earlier to allow me to load and process this file a little bit more quickly. Now it will show me the code in its disassembled way. I can look at that code in its decompiler. Now, this is a different decompiler than the one that I showed you earlier. Sometimes the way this decompiler shows you code is easier to look at than the other decompiler. You want to have options Sometimes one tool works better than another. That's why there are so many tools installed on REMnux that look like they do similar things, but they do those things differently. Sometimes one tool works better than the other. So here you can see that Kappa tells me that virtual protect is happening at this offset. I can go into Ghidra, press the G key to go to that offset, paste that address in, go there. Now I can see this code, look at what it's doing. I'm not sure if I went to the right offset here. Did I? 4010G1. Oh no, it's actually here. 401125. Let's make sure I go to the right address. There we go. This is the virtual protect call in its disassembled form, in its decompiled form. Now, if you've got the expertise, the desire, and the time, you can examine this code. So hopefully you can see now how a lot of the tools available to you as part of REMnux work together. They're intertwined to move your analysis forward. Now, everything that I have shown you so far, you can do while your REMnux environment is connected to the internet, even though really none of the tasks that I performed relied on this internet connectivity. So if you wanted to perform other kind of tasks, you can take your environment, you can, let's say, switch it to your host-only network adapter, if that's what you're using for your laboratory network. And now my REMnux system is in an isolated lab. And in fact, I can use the REMnux command renew-dhcp to make sure I get the latest and greatest IP address. And now this is the same isolated network where I also have my Windows virtual machine. Here, I can infect my Windows system with my malware sample. And if this malware sample will try to access internet-based resources, I have configured my Windows system to use as its default gateway and its DNS server. I've configured it to use the REMnux environment. So now, what does that mean? Now I can use various tools that exist on REMnux to simulate network activity. For example, I can use the fake DNS command on REMnux to fake a DNS server, so that no matter what the malware tries to resolve, when it looks for perhaps malicious domain names, the answer will be the IP address of my Linux box. I can launch Wireshark if I wanted to monitor the network traffic in my lab. I can also, let me activate this tool. Once my Wireshark is running, I can use INetSim, which simulates the presence of many commonly abused services like HTTP and HTTPS. So now I have a fake web server running, I have a fake DNS server running on REMnux. Now I can infect my Windows system with sample.exe, and I have activated fake DNS and INetSim, because I know that when malware infects a system, in many cases, it looks for a DNS server, it looks for a web server. So I'm anticipating that, I'm capturing my network activity using tools that are running on REMnux. And now if I allow my malware to infect the system, I'm hopefully going to see more information about how it behaves. Now, if you're going to be infecting your systems, if you're going to be running malware, you've got to make sure that you're doing this in an isolated laboratory environment. Now, this malware takes a bit of time to properly infect the system. Eventually, as you can see, it spawns another executable named mediacenter.exe. And maybe we now can observe some malicious functionality in the lab. For example, at some point, if we give this malware a little bit of time, we can see that it's resolving that host name that we saw encoded as an obfuscated string inside of our malicious executable. And Wireshark can also show you that when this malware runs, it does reach out to that web server, and it shows you the full HTTP connection that you could use for further investigative tasks. So this is the kind of work that you can do with REMnux. Everything that I have just shown you is captured on the slides that are available to you as a follow-up to the session if you want to go through this analysis. As you can see, REMnux helped us with the initial analysis phases, static properties analysis, static code analysis, and behavioral analysis by simulating tools or other services in the lab. So it's very helpful to pair up your REMnux Linux-based system with a virtual machine in your lab that is running Windows. And really, this is what I wanted to share with you. You got a sense for what's new in REMnux. You saw a sneak peek behind the scenes, and you saw some of the tools in action. There are a lot of tools installed in REMnux. I only showed you a handful of those, so take a look at the docs.rennux.org website to get the full listing. As the next steps, take a look at the documentation site. Also, I prepared and updated the cheat sheet that you're welcome to download to have another way of thinking about using the tools that come as part of REMnux. Set up your REMnux environment, start experimenting, and as you analyze malware using REMnux, publish your findings if you're allowed to do so on the web. Create blog posts, share them with others so that the community can learn how to perform malware analysis and move our state of tooling, our state of skills forward. Now, this is as much time as we've allocated to this session. If you have questions or follow-up comments, please reach out to me. You can contact me on my website, zeltser.com/contact. You can find me on Twitter as well. And I suggest that you keep an eye on the REMnux account on Twitter or Facebook to get updates about this project. Thank you very much for your attention. This is all I have, and we're going to wrap up this session.
All right. Thank you very much, Lenny.